Lessons by H.N. Holzman from the Modern Residential Wiring 9th edition textbook. Lessons format adapted and narrated by H.V. Bayo. This is chapter 4. Section 2, Installation. Section 2 will be divided further into 7 more chapters, which begin with this one, chapter 4, Wiring Systems. Chapters are broken down on your screen. The objectives of this chapter include to know where to find codes and authorities for an installation, to recognize the marks for the most popular testing agencies, to list the different conductor systems used in the residential and light commercial wiring, to list the different conductors or conductor systems used in residential and light commercial wiring, to explain the basics of conduit bending, to become familiar with the many different types of raceway systems, among other objectives. Some of the technical terms described are the anti-short bushing, the armored cable or the AC cable, the authority having jurisdiction or AHJ, the back-to-back bend, the bonding strip, the box offset, BX or BX cable, conduit, electrical metallic tubing or EMT, electrical non-metallic tubing or ENT, field bend, flexible metal conduit or FMC, Greenfield, intermediate metal conduit or IMC, liquid tight flexible metal conduit or LFMC, non-metallic sheeted cable, NM. National Electric Code, NEC, the Nationally Recognized Testing Laboratory, NRTL, Offset Bend, Occupational Safety and Health Administration, OSHA, Raceways, Rigid Metal Conduit, RMC, Rigid Polyvinyl Chloride Conduit or PVC, Romex Saddle Bend Service Entrance Cable or SC, Shrink, Stub Bend, Underground Feeder and Branch Circuit Cable or UF, Underground Service Entrance Cable or USC, Wiring and Wiring System. The National Electrical Code, the most informative and authoritative body of information concerning electrical wiring installation in the United States and perhaps the world, is the National Electrical Code or NEC. It establishes a set of rules and regulations and criteria for the installation of critical equipment. Compliance with these methods will result in a safe installation. The NEC is drafted by a team of experts assembled for this purpose by the National Fire Protection Association, NFPA. This team is formally called the National Electrical Code Committee. They revise and update the NEC every 3 years. It is imperative that anyone installing electrical wiring obtain and studies the NEC. Articles and sections of the NEC are referred throughout this text. Although certain portions, tables, and examples are directly quoted from its text, there is no such useful information in the NEC that it's not having available would be a tremendous hindrance. Code Alert. Articles 90, 100, and 110 provide a necessary foundation to the remainder of the code. Article 90 informs us what and what is not covered in the NEC. Article 100 gives us absolute essential definitions necessary in any conversation regarding electricity. Using inconsistent terms leads to confusion and misinterpretation. Article 110 is the roadmap of the code. Here we find the general requirements for electrical installations and, along with Articles 90 and 100, a solid footing to fully understand the rest of the NEC. State and local codes. Although the NEC itself has no legal basis, it is often made mandatory under local and state rulings. In such cases, it becomes a legal document. The authority having jurisdiction, AHJ, is the person or group of people responsible for approving the equipment, materials, and installation, or a procedure. The NEC is not an AHJ, but is the building commission of your municipality. That may be the AHJ and will probably use the NEC for most electrical installations. The phrase authority having jurisdiction, AHJ again, is used instead of specific title, such as the electrical inspector or county building commission, because the approving systems vary. Code enforcement. Almost every state, region, or locality has some sort of electrical code. Many use the NEC in whole or part. Article 90.4 of the NEC grants full power to the local inspection authority to interpret and modify meanings and intentions of the NEC. Further, some communities add regulations beyond those outlined in the NEC. For these reasons, the local inspector should be consulted for a copy of the local codes. Failure to do so will probably result in violations and inspection failures. Inspection, permits, and licensing. In many areas, permits and licensing are required to do electrical work. In such areas, the utility company requires that permits be obtained and the work be done by or under licensed electrician before they will furnish power. Contact the electrical inspector or power company supervisor for information pertaining to permits and licensing. Equipment and testing agencies. There are many recognized testing agencies throughout the U.S. and Canada. Each of these agencies is known as a nationally recognized testing laboratory, or NRTL, which tests materials and equipment submitted to them by electrical manufacturers. If the materials and equipment submitted measure up to the testing agency's expectations, the items are listed as suitable for electrical installation. In addition, the product will be labeled with a recognized mark to identify the testing agency that approved the product. Almost all reputable manufacturers of electrical materials and equipment submit their products for testing. Products that are not listed should be avoided. In fact, it violates the NEC to use an unlisted product when there are listed ones available. The most widely known testing agencies are the Underwriters Laboratories or the UL, the Canadian Standards Association or the CSA, and Intertech Testing Services, NA, formerly ETL. Products listed by these and other testing agencies are sure to be well constructed and safe. The Occupational Safety and Health Administration, OSHA. The Occupational Safety and Health Administration, OSHA, is the agency with the responsibility of creating and enforcing health and safety standards to protect persons in all occupations within the U.S. OSHA is an agency within the United States Department of Labor. The regulations can be obtained by contacting the Office of Information Services. OSHA, United States Department of Labor in Washington, D.C. These safety regulations are often more detailed than those of the NEC and in some instances supersede the NEC rulings. When in doubt, consult the AHJ, again the authority having jurisdiction. All persons involved in the electrical trade should become familiar with the Osha electrical standards, which specifically address the following areas: hazardous locations, wiring methods, components and equipment, special systems, specific purpose equipment, wiring design and protection, electric utilization systems, definitions and general requirements. A brief history. OSHA. Congress created OSHA under the Occupational Safety and Health Act, which was signed by President Richard M. Nixon. Since its inception in 1971, OSHA helped to cut workplace fatalities by more than 60% and occupational injury and illness rates by 40%. Wiring systems. Conductors for carrying electricity are commonly called wiring. A wiring system includes the wire, its insulating cover, a protective cover, and connectors that fasten it to an electrical box. See Figure 4-4. In some systems, the protective covering and the wire are purchased separately, and the electrician assembles them on the job. In other cases, the protective covering is insulated during manufacture. Depending on the structure being wired, several different systems may be used. Regardless of the wiring system, it is important to have a continuous ground throughout the parts of the system in every circuit. Refer to Chapter 9, Grounding of this text. Grounding requirements. All of these systems are adequate for most installations. Again, refer to Chapter 9's Grounding of this text for grounding requirements. Some cannot be used where there are unusual hazards, such as extreme moisture, explosive gases, or corrosive chemicals. The wiring system selected depends on the type of dwelling or style. Materials and types of construction used, such as log, concrete, post and beam, or platform. Surroundings of dwelling: hot, cold, wet or dry. Cost of electrical materials. Contractor's preference, building code requirements, and the preference of the owner or the client. Cables. A cable is an arrangement of two or more conductors in a protective covering and is assembled by the manufacturer. The protective covering may be plastic, rubber, steel, or aluminum. Armored cable. Armored cable, or AC, is a manufactured assembly of insulated conductors in a flexible interlocked metallic armor. See Figure 4-5. AC, or armored cable, is frequently called also BX, a trade name for armored cable produced by the Sprague Electric Division of General Electric. The conductors in AC may be copper, aluminum, or copper-clad aluminum. The outer covering is called armor and is made of steel or aluminum. As always, see manufacturer's instructions before installing. One of the conductors in the cable is an uninsulated conductor that is in continuous contact with the armor. This wire is called a bonding strip. The use of AC is generally limited to dry locations where there is not subject to physical damage. Thus, it may be used in masonry block, tile walls, attics, and wall spaces, as well as along studs, rafters, and joists. Also, care must be taken to maintain a band radius of the AC that is 5 times its diameter. Armored cable is expressly forbidden for use in commercial garages, hoistways, elevators or cranes, theaters or motion picture studios. AC is quite flexible and can be pulled through bored holes with ease. The holes should be slightly larger than the cable to avoid strain during installation. AC can be measured and cut before it is pulled through the holes in the framing members. Measure the distance along the route the cable will run and transfer this measurement to the cable. Allow 6 to 8 extra inches at each end for making connections. Cut the length of the cable needed using a hacksaw or a reciprocating saw, such as in the one in figure 4-6. Stripping armored cable. There are several methods for cutting through metal armor and stripping the cable end. Regardless of the method used, always be careful not to damage the wires inside of the armor. Hacksaw, the most common tool for cutting the armor, is the hacksaw. The hacksaw blade is placed on the armor so that it makes a diagonal cut across the high ridges. See figure 4-7. Once the armor is cut through, it can be twisted off the inside wires. The aviation tin snips. The first step is to bend the cable sharply where the armor will be cut. This will cause the interlocked armor to disengage. Twist the armor to force it to expand and expose the twist in the armor. Place one of the snips under this exposed section to cut the armor. Remove the armor and trim any sharp corners. See figure 4-8. The roto split. The specific directions will come with the tool when you purchase it, but here are the basic steps to use the roto split. First, place the cable into the channel of the tool. Squeeze the handle to hold the cable in place. Turn the crank until the pressure decreases. Remove the cable from the tool and rotate the armor until it breaks free, such as in figure 4-9. After you have stripped the armor from the cable, you must install an anti-short bushing. This red split plastic sleeve is placed between the wires and the rough edge of the armor. Make sure to place the split on the bushing opposite to the armor and for maximum protection. See figure 4-10. This bushing keeps the insulation from rubbing against the sharp edge of the armor. The bushing must be in place to pass an electrical inspection. Purchase plenty of bushings when buying armored cable. When the anti-short bushing is in place, bend the bonding strip back over the bushing and wrap the cable as shown. Add the connector and tighten the screw set. Add the connector and tighten the set screw or the clamp. The set screw type of connector cannot be used on aluminum AC or armored cable. See figure 4-11. Code alert, section 320.100. Construction of the type AC cable shall be an armor or of flexible metal tape and shall have an internal bonding strip of copper or aluminum in intimate contact with the armor for its entire length. Non-metallic sheeted cable. The non-metallic sheeted cable, or NM, has 2 or more insulated conductors wrapped in a strong plastic or braided outer sheath. Often included is a bare copper ground wire Figure 4-12. NM, or non-metallic sheeted cable, is the easiest and in many areas the most popular system to install. NM is easily cut to length with cable cutters. A cable ripper is used to split the outer jacket from the point where the wires will be exposed to the end of the cable. Place the cutting tooth in the center of the cable about 8 inches from the end. Squeeze the ripper closed to pierce the jacket and pull it to the end of the cable. Use a knife to carefully cut the jacket completely off the cable. See figure 4-13. Quick history brief. Romex, the type NM cable, is referred to almost universally as Romex, regardless of which company makes the cable. Originally developed by General Cable in Rome, New York. In 1922, NM cable is now made by many different companies. Code alert. At least section 300.14, at least 6 inches of free conductor measured from the point in the box where it emerges from its raceway or cable sheath shall be left at each outlet, junction, and switch points for splices or the connection of luminaires, fixtures, or devices. Where the opening to an outlet, junction, or switch point is less than 8 inches in any dimension, each conductor shall be long enough to extend at least 3 inches outside of the opening. Service entrance cable. Service entrance cable, or SE, may be a single conductor or a multi-conductor assembly with or without an overall covering. It is used to bring electricity into a customer's building from an overhead utility pole. Underground service entrance cable, or USC, is used to supply electricity underground. Stripping the insulation off of the conductor is done with an electrician's knife. Cut into the insulation around the circumference of the cable without nicking the conductor. Cut the insulation lengthwise from the first cut to the end of the cable. Now peel off the insulation. Since the conductors in these cables must be large enough to handle the power requirements of an entire building, they may be stiff and difficult to work into position. A cable bender is handy to create small radius bends in the heavy cable. Underground feeder and branch circuit cable. The underground feeder and branch circuit cable, or UF, is a non-metallic sheatheded cable that is run underground between the service equipment and the final branch circuit overcurrent device. A typical installation would be a branch from the main service panel to a detached garage. Although the materials in UF are designed for underground use, the cutting and stripping procedure is exactly the same as standard NM cable. As with all underground cables and conduit, review the local codes for proper burial depth. Raceways. Raceways are protective coverings installed on site and used to contain wires. Raceways or raceway materials are selected depending on the intended application, wire size and opacity, environment, installation conditions, new or remodel, building codes, and cost are all factors that will determine the selection of a raceway. Raceways consist of conduit boxes and fittings. Conduit is the tubing connecting the boxes together. The wires are pulled from box to box through the conduit. Boxes could be used for either junctions or to connect the wires or mounting devices such as lamp fixtures. Switches and outlet receptacles, fittings, are used to connect pieces of conduit together, and connections are used to connect the conduit to the boxes. Electrical metallic tubing. The electrical metallic tubing, or EMT, is called a thin wall conduit. EMT is not designed to be threaded, therefore it is connected length to length or to electrical boxes with suitable compression or set screw fittings. When installed correctly, EMT is used as an effective equipment grounding conductor. See figure 4-14. Conduit. The first step when cutting conduit is to secure the conduit in a vise. This will help you make straighter cuts and avoid broken blades. If a vise is not available, brace the conduit against a secure surface such as a wall, stud, or a sawhorse. A hacksaw is normally used to cut all types of conduit. A reciprocating saw outfitted with a metal cutting blade is also used to cut conduit. Either saw would be fitted with a blade having 18 to 24 teeth per inch for a clean cut. See figure 4-15. A square cut can be made with a pipe cutter, although it creates a larger burr. Apply a small amount of cutting oil where the cut will be made. Slip the cutter mouth over the conduit and adjust the cutter wheel until the tool is snug. Rotate the cutter around the conduit. If the tool is too difficult to rotate, the wheel is too tight. Adjust the cutter wheel until the tool is firm but not difficult to rotate. Continue to rotate the tool and tighten the cutter until after each turn until the conduit is completely cut. See figure 4-16. Reaming conduit. The ends of a length of conduit must be smooth to prevent any damage to the wire's insulation. After cutting the conduit, use a reamer or round file or a deburring tool to remove the burrs. See figure 4-17. Bending metallic conduit. The purpose of bending conduit is to route it around corners and over obstructions. There are numerous special manufactured fittings available that could be used to achieve similar routing, but field bends are preferred. Field bend. A field bend is a bend that is made on the construction site. This generally saves time and is far more economical than installing fittings. Most bends in EMT are made with a conduit bender. Always use the correct size bender for the conduit you are bending. This tool is designed to create a bend with the proper bend radius. The NEC lists the minimum radius of construction conduit in the minimum radius of conduit bends in Chapter 9, Table 2. Typical bends include stub, also known as stub up, back to back, offset, and saddle. The following sections will help you make these fundamental bends. Bending conduit is an important skill that you can master with practice. The stub bend is the first bend that we'll describe. It is a 90-degree bend that usually brings a horizontal run of conduit up or down to an outlet box. Practicing this basic bend will help you become familiar with the conduit bender. Measure the height of the total bend. This is typically from the bottom of the horizontal conduit to the bottom of an electrical box. Take this distance and subtract the radius of the conduit bender. The resulting number of the distance is the distance to mark from the end of the conduit. Place the conduit in the bender with this mark aligned to the bender's arrow. Press down on the foot pedal of the bender while guiding the handle to keep the bend perpendicular to the floor until the stub is 90 degrees. Use a torpedo level to confirm that the stub is vertical. See figure 4-18. A back-to-back bend. A back-to-back bend produces two 90-degree bends on a single length of conduit. After the bends are made, both ends of the conduit are pointing in the same direction. Step 1 is to create the first bend by following the stub bend procedure, the one we just described. Number 2, mark the distance from the outside of the first bend to the position where the outside of the second bend should be. Number 3, place the conduit into the bender so that the star point is aligned with this mark. Number 4, create the second bend. Number 5, mark the conduit where the height of the second bend should be. Number 6, cut the second bend at the mark. This is much more accurate than trying to control the height prior to bending, as you would while making a stub bend. See figure 4-19. Offset bend. The offset bend is used when the conduit must go around an obstruction or when the plane of the conduit must change slightly. Generally, offsets may be done at almost any angle, but shallow bends, those at smaller angles, reduce the force required to pull the wires through the conduit. Deeper bends will bring the offset closer to the obstruction, but will make it more difficult to pull the wires. Figure 4-20. Another important factor when the bending conduit is shrink. Shrink is the amount of shortening in a length of conduit caused by adding one or more bends. See figure 4-21. The angle and the distance between the two bends in an offset will influence the amount of shrink. Fortunately, this amount has been calculated and is available in the offset bend table. If the offset bend is going to occur after the obstruction, shrink does not have to be added into the bend location. Regardless of whether you create the offset before or after an obstruction, the bends will be made on the side of the mark that points away from the obstruction. See figure 4-22. Review the following procedures and compare the steps for creating an offset bend before and after an obstruction. In all types of bends, the amount of shrink depends on the size of the conduit. Shrink varies with bend radius, and each size of conduit must be bent to the proper radius. Offset bend before an obstruction. Step 1 is to measure the height of the offset. Step 2 is to measure the distance between the connection point and the offset. Step 3 is to look at the offset bend chart and determine which angle you would like to use for the offset bends. Look at the offset bend chart to determine the shrink and the distance between the bends. Add the shrink amount to the distance you measured in step 2. Place a mark on the conduit at this calculated distance. Take the distance between bends found in step 4 and mark the conduit back from the first mark. Place the conduit bender handle on the floor and secure it in place with your foot. Place the conduit in the bender so that the first mark is aligned with the arrow. Bend the conduit to the angle determined in step 3, being careful not to kink it. Without removing the conduit from the bender, rotate the conduit 180 degrees and slide it until the second mark is aligned with the arrow. And the last step is to bend the conduit to the angle determined in step 3, being careful not to kink it. Offset bend after an obstruction. Measure the height of the offset. Make sure the distance between the connection point and the offset, or measure the distance between the connection point and the offset. That's step 2. Step 3 is to mark the conduit at this distance. Step 4 is to look at the offset chart and determine which angle you would like to use for the offset bends. Step 5 is to look at the offset bend chart and determine the distance between the bends. Step 6 is to take the distance between the bends and mark the conduit forward from the first mark. Step 7 is to place the conduit bender handle on the floor and secure it in place with your foot. Step 8, place the conduit in the bender so that the first mark is aligned with the arrow. Step 9 is to bend the conduit to the angle determined in step 4, being careful not to kink it. Step 10, without removing the conduit from the bender, rotate the conduit 180 degrees and slide it until the second mark is aligned with the arrow. And step 11 is to bend the conduit to the angle determined in step 4, being careful not to kink it. Professional tip: keeping bends aligned when putting 2 bends in a piece of conduit. They must be in perfect alignment, so the conduit will lay flat against the wall. If one bend veers to the left and the other veers to the right, the conduit will not lay flat. To maintain alignment, find a seam in the concrete or tile floor, line up the first bend and the bender with the seam to keep the second bend properly aligned. The box offset bend. An offset that is used frequently is called a box offset. The box offset brings the conduit off the mounting surface so that it can fit into a knockout hole of an electrical box, such as the one in figure 4-23. Step 1 is to place one mark 2 inches and another at 8 inches away from the end of the conduit. Step 2, place the conduit bender handle on the floor and secure it in place with your foot. Step 3 is to place the conduit in the bender so that the 2-inch mark is aligned with the arrow. Step 4 is to bend the conduit to a 5-degree angle. Step 5 is, without removing the conduit from the bender, rotate the conduit 180 degrees and slide it forward away from you until the second mark is aligned with the arrow. Step 6 is to bend the conduit now in the opposite direction to a 5-degree angle. Saddle bend. The saddle bend goes around an obstruction and, unlike the offset bend, returns to the same level after passing the obstruction. The most common saddle consists of one 45-degree center bend and two 22.5 lateral bends. See figure 4-24. Step 1 is to measure the height of the offset and the distance between the connection point and the offset. Step 2, for every 1 inch of obstruction height, move the center mark forward 3/16 of an inch. Assuming a 1/2 inch conduit is being used, mark the conduit with this new center mark. Number 3, lateral marks are placed 2.5 inches away from the center mark for every inch of obstruction height. Place the mark on each side of the center mark. Number 4, place the conduit bender handle on the floor and secure it in place with your foot. Number 5, place the conduit in the bender so that the center mark is aligned with the rim notch or the teardrop mark. Number 6, bend the conduit to 45 degrees, being careful not to kink it. Number 7, without removing the conduit from the bender, rotate the conduit 180 degrees and slide it forward. Slide the first bend away from you until the lateral mark closest to you is aligned with the arrow. Number 8, bend the conduit to 22.5 degrees. Number 9, remove the conduit and flip it end for end. Place it back in the bender with the second lateral mark closest to you. Number 10, line up the second lateral mark with the arrow and bend to 22.5 degrees. Electrical non-metallic tubing. A newer type of plastic corrugated raceway called electrical non-metallic tubing, or ENT, is now recognized for general use by the NEC under Article 362. It is flame retardant and is resistant to moisture and chemical atmospheres. ENT can be used in almost any building or dwelling regardless of height and can be concealed behind walls, above ceilings, or embedded in concrete. Being lightweight and flexible, ENT is easy to handle. The various connectors, couplings, and fittings are attached with snap locks or plastic bonding cement. Installation varies and should be performed according to the manufacturer's instructions. See figure 4-25. There are some restrictions and limitations to the use of ENT. It cannot be used for hazardous material, cannot be left exposed with some exceptions, should not be used as supportive means, cannot be used for direct burial applications, and cannot be used for voltages exceeding 600 volts. History brief. The Smurf ENT is referred to in the trade as Smurf tube or simply Smurf. The distinctive blue color found on most but not all ENT is the reason for its nickname. Smurfs were bright blue cartoon characters that were popular in the early 1980s. Rigid metal conduit type, RMC. Rigid metal conduit, or RMC, is galvanized and somewhat similar to water pipe. It is used for both indoor and outdoor applications. Inside and out, the conduit is smooth and can be cut, threaded, reamed, and bent. It's necessary for proper installation. To cut RMC with a pipe cutter, follow the cutting procedure demonstrated in the previous EMT section. RMC must be firmly connected to items such as electrical outlet boxes and panels with a threaded lock nut or bushing. This solid connection is necessary because the conduit itself serves as the equipment grounding conductor. Thus, a separate equipment grounding conductor is not required when using RMC. Fittings should maintain a continuous ground throughout the system. See Figure 4-26. Code alert, section 344.46. Where a conduit enters a box, fitting, or other enclosure, a bushing shall be provided to protect the wire from abrasion unless the design of the box, fitting, or enclosure is such that to afford equivalent protection. Threading RMC. Number one step to threading RMC is to clamp the conduit into a pipe vise. See Figure 4-27. Place an appropriately sized pipe reamer inside of the end of the conduit. Rotate the reamer until all burrs are removed from the inside of the conduit. Remove all burrs from the outside of the conduit with a file. Mount a threading die inside of the head of a hand threader. See manufacturer's instruction. Add cutting oil to the end of the conduit to ease the cutting and prevent tool wear. Place the threading die squarely on the end of the conduit. Rotate the hand threader while pressing its head toward the conduit. The die will engage the conduit and start cutting threads. Stop pushing the head and continue rotating the hand threader. Add cutting oil to the conduit after every few rotations. When the end of the conduit is even with the back of the threader die, stop the rotations. Reverse the direction of the hand threader to remove it from the conduit. Lastly, clean off the threads with a rag and remove the conduit from the vise. Rigid PVC conduit. Rigid polyvinyl chloride conduit, or PVC, is constructed of polyvinyl chloride. It is a tough, non-conductive plastic. PVC weighs much less than metal conduit and is designed to be used everywhere other types of conduits are used. There are many types of fittings available to connect the PVC to non-metallic and metallic boxes and conduit. See Figure 4-28. PVC is only restricted in certain hazardous locations and where it could be physically damaged. Check with your authority having jurisdiction, or AHJ, to see if local code permits its use. Do not use to support fixtures. PVC is easily worked. It can be bent using special bending boxes with heating elements to warm the conduit. This allows it to be easily bent by hand using a simple bending jig. Performed bends may also be obtained. To connect the PVC and fittings, a special glue and primer are used. See Figure 4-29. Attaching fittings to PVC. First step is to clean the inside of the fitting and the end of the conduit with a rag. Dry fit the fitting on the conduit to check the final position. Remove the fitting. Apply primer to the inside of the fitting and the outside of the conduit. Apply cement to the primed areas. Push the conduit into the fitting while turning the fitting a quarter turn. Look at the seam for a bead of glue to indicate a proper amount of cement. Note, the NEC 225.27 requires conduit run underground to be sealed at joints prior to entering the building. Intermediate metal conduit, IMC. is permitted for use in all atmospheric conditions and all types of occupancies. Like its counterpart, rigid metal conduit, IMC, is available in 10-foot lengths. Each length or part of length must be properly connected and joined to other lengths or enclosures using the correct fitting. IMC is available with or without threads. Installation is the same as rigid metal conduit. Professional tip: intermediate metal conduit. The internal diameter, or ID, of IMC is larger than that of the equivalent trade size RMC. Therefore, there is more room for pulling wires and calculating conduit fill. Flexible metal conduit, or Greenfield. The flexible metal conduit, or FMC, is a spiral wrapped metal conduit similar to the outer armor in AC. See figure 4-30. FMC is often called Greenfield because it was invented by Harry Greenfield. FMC is routed and attached as if it was non-flexible conduit, but it has the advantage of bending without using tools. There are special couplings, lock nuts, and bushings for attaching FMC. The wire is fished through as with other conduit. Code alert, section 348.60. Were used to connect equipment where flexibility is required after installation. An equipment grounding conductor shall be installed. Where flexibility is not required after installation, FMC shall be permitted to be used as an equipment grounding conductor when installed in accordance with 250.118.5. Frequently, FMC is used with EMT, or rigid conduit. It is substituted where the bends are needed. Instead of making complicated bends and angles in EMT or rigid conduit, a section of FMC can be inserted. There are special bushings, lock nuts, and couplings to connect FMC to the other forms of conduit. There are also length limits as stated in the NEC. Liquid tight flexible metal conduit. Liquid tight flexible metal conduit, or LFMC, is similar to FMC, but LFMC is covered with a continuous plastic sheath. This system is easy to install and can be used in most locations. In residential installations, LFMC is typically used to connect a central air conditioner unit to a disconnect. See figure 4-31. Its extreme flexibility makes LFMC an optimum choice to connect machinery that is portable or may vibrate during normal operation. LFMC is also permitted as a service wiring method up to 6 foot in length. The use of LFMC requires the use of some special fittings and connecting procedures. Surface mount raceways. Surface mount raceway is an assembly of two sections, a base and a cover, that is generally rectangular or flattened oval. Sections are 10 foot long and range from 3/8 to 3 inches high in form and from 1/2 inch to 4 inches wide. Surface mount raceway is constructed of steel, aluminum, or plastic. Surface mount raceway is mounted on wall or ceiling surfaces only in dry locations and where it will not be subjected to physical damage. Elbows, connectors, and couplings and boxes are designed to be electrically and mechanically continuous and compatible. It is useful in existing facilities when appearance is important and new wiring cannot be pulled through walls. And finally, some review questions. Number 1, name 5 key factors that determine the wiring system used for a particular installation. First factor is the cost of materials and labor, the environment, the regulation, the type of dwelling, and customer preference. Number 2, true or false, when wiring with rigid metal conduit, a grounding conductor is required. False, a grounded conductor is not required when wiring with rigid metal conduit. The rigid metal conduit could be a ground path. Number 3, when rigid conduit is cut, it is important that it be blank to remove any sharp burrs that could damage the blank during the wire installation. The answer is reamed to remove any sharp burrs that could damage the conductor insulation. Question 4, a blank must be added to rigid conduit to protect the wires that are pulled, and that would be a bushing must be added. Question 5, intermediate metal conduit is commonly sold in which of the following lengths? And of course that's D, 10 feet. Number 6, a blank bend is used when the conduit has a 90-degree turn, has to turn 90 degrees. That would be a stub bend. Number 7, flexible metal conduit, or FMC, is also called Greenfield. Number 8, LFMC stands for what? Liquid flexible metal conduit. And the liquid means that is liquid tight. Number 9, armored cable is known as AC and what else? BX. Number 10, lists 3 places where the armored cable cannot be used, and that is commercial garages, hoistways, elevators or cranes, or theaters or motion picture studios. True or false, electrical metallic tubing cannot be used as an equipment ground, and that is false in most locations. It could be used many times as an equipment ground. Number 12, which article of the NEC outlines rules regarding the rigid metal conduit? And that would be Article 344. 13, the following are the types of nonmetallic sheeted cable: NM, NMC, NMS. Where are each of them used? NM is normally dry. NMC is for moist, damp, or corrosive. And NMS is again normally dry. 14. Which article of the NEC outlines the rules regarding rigid nonmetallic conduit? And that would be Article 352. Question 13 was already answered. Question 14, which article of the NEC outlines rules regarding rigid nonmetallic conduit? And that is Article 352. The know the code questions. What is the title of section 250.118? 250.118, an important one, is the types of equipment grounding conductors. Very important article of the NEC. What does the informational note in section 320.10 say? And it says that construction type AC cable shall have an armor of flexible metal tape and shall have an internal bonding strip of copper or aluminum in intimate contact with the armor for its entire length. Question 3, true or false, underground feeder or UF can be used as a service entrance cable, and that is true. That brings us to the end of the chapter, chapter 4, wiring systems. Thank you for listening and reviewing and studying this chapter. Continue your studies and you will be on your way to being a professional electrician. Please look for the next chapter and others beyond. Good luck with your studies and have a good time. Thank you. This has been Electrician Program, Chapter 4.